Well, we start with our screw gauge experiment. The experiment is to determine the thickness of an irregular lamina, or you can have a diameter of a narrow wire. Diameter of a narrow wire or thickness of the lamina, both using the screw gauge. So let's start with the lamina, irregular lamina. In the same procedure, you can find out the diameter. Instead of a lamina, you will put the diameter on the table and find it out. The procedure is the same. So let's highlight on the determination of thickness of a glass piece using, that is an irregular lamina, using a screw gauge. Apparatus required, you have a screw gauge and a glass piece. That is, or if you have a screw gauge or a narrow wire. If you are having a narrow wire, you will have screw gauge, narrow wire. And if you are given the problem as a lamina, that is your glass piece, you will write the apparatus required, screw gauge and glass piece. I told you in the theory part, you begin with the working formula. Here is the working formula. The thickness, or if your diameter is asked for you, both will have the same answer. Pitch scale reading in centimeter plus circular scale reading in centimeter. That is pitch into number of complete rotations n into plus the circular scale reading is extra circular scale division b multiplied by least count. Extra circular scale division, all that part I will be explaining you gradually, but since this is a formula, I have to write I difference f, not I minus f. I is initial circular scale division, difference f, final circular scale division multiplied by least count. So what is the working formula for the thickness? Pitch scale reading plus circular scale reading. That is pitch into number of complete rotations in centimeter plus d into circular scale divisions in centimeter. Now, then here you will have the working formula. Here this is again repeated here. What is I? Initial circular scale division. I just told you f is the final circular scale division. Now, this small d that I have written, d is equal to extra circular scale division. Now, d is I minus f for I greater than f. d is 100 plus I minus f for I less than f. Before I start with the instrument, what is the screw gauge? Why we use the screw gauge? Let me just keep it over here. We have just known what is the working formula, the apparatus, and your aim of this experiment. We know this. So let's go to the diagram. The screw gauge. I'll come back to the extra circular scale division later on. Now here, look at this. This is a C frame. This is for holding. This metallic frame is for holding, and it has a stationary stud, which is your this part is your anvil, and then the zero adjustment screw. There is the anvil, and there is a movable stud, which is called the spindle. The spindle moves through the lock nut, the sleeve, and your ratchet. So here you have a ratchet which has a screw movable part. It will be the screw moves under the nut. If someone asks you, does the screw move under the nut or above the nut? The screw moves under the nut. And these are the parts of this instrument. It works on the principle of screw. I will come to that later. First, let me explain the part. A metallic frame, it can be a U-shape or a rectangular frame. It's just only for holding, okay? And the instrument is kept in between these two parts of the micrometer. This is called a micrometer screw, okay? So this is the stationary part, this is the movable part. In between this opening, here you keep the glass piece or even the hair diameter or even the diameter of a wire. It all has to be kept inside these two openings, and you move your ratchet in the forward direction so that it just closes and there's a scratch sound there. That sound, don't overdo it. Just a little sound which gives you that it has closed. Okay? So this is part is for holding, and this is for you to hold this, the instrument. There is a zero adjustment screw, and the sleeve here it is having a baseline which is called a lateral line or a reference line. Look at this, a reference line. If I open this, see it is open, you'll see there is a scale coming up. There is a scale coming up. 0, 5 and 10. So 0, 5 and 10. So this is called your linear scale. This is your linear scale. And then there is a circular scale here. This is a circular scale. So if I look into the diagram here, see the diagram. This is your linear scale and this is your circular scale. This is your ratchet, which are the moving part. Now, when you close these two openings, If the zero of the linear scale, if the zero of the linear scale coincides with the zero of your circular scale, when the two openings are closed, then there is no zero error. Here also it is an error. If the main scale is 0, when you close it, it lies above, then there is a positive 0 error. Then if you close it, if the main scale is 0, that means the linear scale is 0, not the circular scale. How many divisions are there in the circular scale? 100. It is, sometimes it is 50 also in some scale borders. So you can say this is your circular scale and this is your linear scale, which is in a line. This line is called a lateral line or a reference line. In the reference line, this linear scale, 0 of this line, 0 of this scale, if it is lies above the 0 of the circular scale, it is positive 0 error, and if it is lying below, it is the negative 0 error. So the skew gauge has this 0 error. Now, this part, screw gauge. Gauge is a unit of length, and screw gauge is an instrument based on the principle of screw. My dear, what is a screw? Screw is a simple machine, like you have lever or an inclined plane. And here, it works on the principle of screw. The screw moves under the nut. And then suppose you have the, suppose I put a wire like this, just a sample. Then you will have to find out the coincidence of the circular scale division on the lateral line. That will give you the initial. You slide it and displace it, remove it, bring the initial back, and then see how many times the eye goes. This is how you do it. But before that, what's the thing that you must know? Like in one day you want to find out the least count in the zero error. I just told you about the zero error. But what about the least? What is the least count? The screw gauge, if you can measure the diameter even in a vernier caliper, but why do you need the screw gauge? It has an accuracy of 3 decimals. It still measures lower lengths. So, we use a screw gauge after an accuracy of 0.0005 cm or 0.001 cm, depending upon how many divisions you have in your linear scale. If you have a linear scale having 10 divisions, you will have a least count of 0.001, and if you have 20 divisions in the linear scale, you will have a least count of 0.0005 cm. So, this is how it is an accuracy of these many decimals. So, it is even the diameter of the hair can be determined by screw gauge. And there's a very first questions they are asked exam, what's the difference between a rain gauge and a screw gauge? Both are gauges, right? Rain gauge determines height of rainfall, the screw gauge determines the thickness, diameter of a wire. Okay, now we begin with something called pitch. So let's go to the theory part, the pitch. So before we start with the pitch, let me tell you, when you determine the pitch, first open it slightly, move the screw head so that the 10th line of the linear scale coincides with the 0 of the circular scale. The 10th line of the circular scale coincides with the 0 of the circular scale. Here. Like this. The 0 of the circular scale, let me tell you, the 0 of the circular scale coinciding with the lateral line. Okay, this is 10th line, the 10th division of the linear scale is perpendicular. This is the 10th division and this is the 0. This is in the lateral line, the 10th division of the linear scale is here and there is a 0 here, perpendicular to it. Now give rotations, 10 complete rotations. Let the 0 of the circular scale cross this lateral line 10 times. Now it has crossed once, twice. It will, in this way, you continue for 10 complete rotations. This is to be going for how many divisions it crosses. In 2 rotations, it has gone 2 divisions. Don't count it like that. You completely show that it passes through. Let me just see where the zeros crosses. The 0 is allowed to pass through the lateral line 10 times. 8, 9 and 10. It has completed 0. So that means how many divisions it has covered? First you will see, look into the linear scale. The linear scale means there are only 10 divisions. The linear scale has 10 divisions. 10 divisions is equal to 1 cm. I told you it will have, then if it is 10 divisions, then each division of the linear scale is how much? 0.1. 10 division is 1 cm. So 1 division of the linear scale is 0.1. Now I have done 10 complete rotations of the circular scale. And it has covered how many divisions here? It has reached from 10th to 0. How many divisions it has covered? 10 divisions. So in 10 complete rotations, it has covered 10 divisions. So in 1 complete rotations, 1 division. Okay? So 1 division means how much centimeter it has covered? 0.1 cm. And that's what we mean by pitch. Pitch means if you give a full rotation of the zero, that means 100 divisions to rotate, how much distance? Here the circular scale has 100 divisions. If the 1 complete rotations, how much distance it covers on the linear scale? It has covered only 1 division. That means it has covered 0.1 cm. Now, if you are given a screw gauge where there is small large divisions between 0 and 10, 20 divisions, then there will be 20 divisions equal to 1 cm. So what will be 1 linear division? 0.05, 1 by 20. So there you will not write 0.1 as pitch. If it is 10 complete rotation goes 10 divisions and it goes, there it will not reach 0. It will, in between 5 and 10 it will have 10 divisions. So if you give 10 complete rotations, that 0 of the circular scale reaches 5th division in those who have 20 divisions in the linear scale. So that is again it has also covered 10 divisions. In either of the screw gauges, you will have 10 complete rotation, it goes 10 divisions. 1 complete rotation, it goes 1 division. But in this case, the linear scale is standardized to be 0.1, the least count of the linear scale is 0.1. So the pitch is 0.1. Okay? And there the pitch would have been 1 by 20. 0.05. So you can have two varieties. So you cannot write sometimes 0.1 and sometimes 0.05. Whatever is there in your screw gauge, first you count. So what is the first step in your screw gauge? After seeing that it is proper, it is not loose, take a proper screw gauge and then see how many divisions are there on the linear scale. If there are 10 divisions, then it is 0.1 cm. If it is 20 divisions, it will be 0.05. Now, so what is pitch? So here, pitch is, I have written here, the linear distance travelled by the circular scale over the linear scale during 1 complete rotation of the circular scale. What is pitch? The linear distance travelled by the circular scale over what? Over a rod? No. Where is it moving? The circular scale is moving over the linear scale. This linear distance covered by the circular scale over the linear scale during 1 complete rotation. Mind you, that complete, please put an underline there because that's important. Complete rotation of the circle. It will not be a half rotation, it will be complete. 0 has to cover the lateral line once. Then the distance, or you can also say that it's the distance between 2 consecutive threads of the screw. You will see that the ratchet will open, in the scale, in the spindle you have the threads. So this is distance between 2 consecutive threads of the screw. Now what is least count and how we determine it? I'll write the later on the least count. Least count, you don't write it is the minimum distance covered by the screw. Please don't write. In the screw gauge, what's the least distance it can cover? You can measure. This is a measuring instrument, for length measuring instrument. So you can say that the linear distance, how much pitch has gone? In 100, how many divisions are there in the circular scale? 100 divisions. So 100 divisions rotate and go a distance equal to pitch, that is 0.1. So one smallest division will go pitch by 100 or pitch by number of divisions of the circular scale. If we had 50, then pitch by 50. But here in this case it is 100. So it will be 0.1 by 100, which will be 0.001. So what is the least count definition? Linear, here it is a linear distance. Least count is again a constant of the screw gauge. Pitch is also a constant. Pitch is 0.1 cm, least count is 0.01. It is the linear distance travelled by the circular scale over the linear scale during 1 smallest division rotation of the circular scale. What is this now? Pitch divided by total number of divisions. That is 0.1 by 100 in my case. Okay. So, I have told you about the pitch and the least count. So, what is the least count in my case? 0.001. What is pitch in my case? 0.1. We will be doing when you come to the observation. We are still in the practical theory. I told you what was the working formula for the thickness of this is the glass piece. If I put it here, yes. So here, this glass piece is inside this. So I have already determined pitch and I have already determined least count. What was the formula? Thickness of the glass piece is PSR into plus CSR. That is pitch into number of computation. CSR, circular scale reading in centimeter, is extra circular scale division into least count. And now I am explaining you the the extra circular scale division we use in a theory called circle of reference. Now, small d I wrote in the theory, that was I minus f. Go to the theory part. It was d is here. I have written I minus f for I greater than f. I 100 plus I minus f for I less than f. For what kind of a rotation? When you rotate, you will have 90, then it comes 80, 70, decreasing order rotations. Now, in a micrometer, when you are closing, if it is decreasing, opening it will be increasing in another case. So, micrometer by my there are several micrometers where it will have a decreasing order or a increasing order. But increasing order rotations will be different. F minus I for F greater than I and 100 plus F minus I for F less than I. So, that's that part you must know that in our case, it is a decreasing order rotations. So, let's go to the circle of reference. The circle of reference here, it is 100 or 0. Your 100 is decreasing to 75, 50, 25. It's a decrease. This is a clockwise rotation. This is a clockwise rotation. Suppose your initial is 35. Where will be the reading? That means, suppose here the circular scale division 35 is coinciding with the lateral line. When you touch the glass, the two openings are touching the glass face. Then, the 35 is here somewhere. 35 here. Now, 35 will decrease to 0. So 35 minus 0, 35 divisions. Then so final, when the two openings close, you get the final. So final is suppose 75. So what will be this? Initial is 35, final is 75. How much it has moved? 35 says 0, it goes 35 divisions. From 100 to 75 is 25 divisions. 35 plus 25, 60 divisions. And what is the formula for this? See this? I is 35, final is 75. 135 minus 75, 60. I showed you in the diagram, from 35 it goes to 0 and from 100 it goes to 75, again it is 60. So for a clockwise rotation, it will give you that I plus, that is your formula, if I is less than f, I is 35, if I is less than f, the formula used always for the sleep experiment is 100 plus I minus f. For a clockwise rotation, mind you. And for an anti-clockwise, it is f minus I and 100 plus f minus I, which you know in the higher classes. Okay, so let's first take a reading, then we go over to the procedures. Okay, we have finished the aim part, apparatus part, theory part, explanation of circle of reference, and then we go to the procedure. Before I scroll on to procedures, let me tell you how we determine the pitch first. So what I told you, I have already told you the pitch. First, you open it. See between 0 and 10 how many divisions are there in the linear scale? 10 divisions on the linear scale equal to 1 cm. You have standardized the linear scale as 0.1. Then put the 0 of the circular scale coinciding with the 10th line, so the 10th line is perpendicular. Take a forward rotations, 10 complete rotations, it reaches 0. So in 10 complete rotations, it goes to, let me tell you that, in determination of pitch. So you have standardization of linear scale. 10 linear divisions equal to 1 cm, or if you have a screw ball, you have a 20 linear divisions equal to 1 cm. So that part is 0.05. You have, in our case, it is only 0.1. You cannot write both. It is 0.1 pitch. Now, the 0 of the circular scale is made to coincide with the 10th mark of your linear scale. Next, screw head is given rotations, and the 0 of the circular scale is made to cross the lateral line 10 times completely. Then you note how much distance it is covering. So in 10 complete rotations, this you have to write here. You have to write that in your observations. That during 10 complete rotations, how many divisions it covered? It went from 10 to 0. So in 10 complete rotations, linear distance covered by the circular scale over linear scale is 10 divisions on the linear scale. So in one complete rotation, linear distance covered by the circular scale over linear scale is 1 division. And what is your 1 division? 0.1. So pitch is 0.1. So pitch, first table, first column is finished, 0.1. And what is your least count? I told you pitch divided by 100 divisions. So that also I have written it. In 100 divisions rotation, linear distance covered by circular scale over linear scale is 1 division. In one smallest division rotation, linear distance covered by the circular scale over the linear scale is 1 by 100 division of the linear scale. So that is 0.1 by 100, that is 0.0016. That's how we use the least count. But in case of in the another screw ball, that's why with the dash mark, it is for the second part. If you are given a different screw ball where you have 20 linear divisions, then the least count will be how many? 3 zeros 5. Mind you, if you remove 1 zero, all the entire experiment goes wrong. Okay? These are the constant of the instrument. So my dear, go to zeros. Okay? Here you have 0.001c in our linear scale if you have 10 divisions. So let's go to this. So the pitch is 0.1. We have finished with pitch, the least count as 0.001. Now what is initial circular scale division? We'll put it here. We'll put the glass piece here, and there is a sound. Then you will see here you have the 62th division is coinciding. Just that is initially 62. What is 62? The reading on the circular scale coinciding when the two openings are closed, coinciding with the lateral line. That is the 60th. Just little highlight the 60th or remove and bring it back to 62. That is 62. 62 is the initial. See how many times 62 crosses. Yes, it is covered 11 times. Then you can say that the final is, suppose here it is 85. That is closing. The closing part is 85. So when the two openings are closed, just a sound. Don't overdo it. Just a sound. So you can say the final can be written 85, and the initial is how much? 62. How many rotations the 62 has crossed the lateral line? 11 times. Okay, so 11 times is not, so n part, so you will write there in the n part, your n will be 11, initial will be 62, and the final will be how much? 85. So in that way, you can put it here, you have it here, the initial is 65, final is 85. The initial is 62, sorry. Final is 85. Number of rotations 11. Now, what will be your pitch scale reading? Number of rotation multiplied by pitch. And what was your pitch? What was your pitch? 0.1 cm. So what will be your pitch here? 11 into 0.1. So what will be this? Okay, 1.1. Now, here, look at this. I is less than F. So, what will be your formula here? 162 minus 85. That gives you 77. D is 77. What will be your circular scale reading? 77 into 0.01. 001, sorry. So, this will be 0.077. Okay. And this will become 1.1 plus 0.077. This is 1.177. Something like this. Okay. So you will go on finding out like this. So again, the initial can vary within 10 divisions. The final can be closed 84. The closing will be, how we check it. The final will be more or less the same value, more or less. It may not be, but doesn't mean that it will vary between 1 to 2 divisions. Whereas initial, because this is not a regular, this is not a uniform thickness. So initial, suppose you put a boundary where you are taking it. If I take it, maybe it is 40, no? You please put a boundary where you are taking it. So because if it is not a since it's a large lamina being provided, then if it is, so you put a boundary and take the thickness here and measure the I there. So that I also varies between 10 divisions. So I can vary from 62 to 52. So it can vary between this. So the next reading if I go on taking, it might be, instead of 62, it might be 60. Then the final might be 85 or 84. But the number of rotations will be 11. So then, in that case, it will be again 1.1 here. And what will be your difference? 60, what will be your 160 minus 84? So it will be 676. So it will be 0.076. So 1.176. Something like that. So all these readings will be 1.177, 1.176. So you will have 10 such readings and then take the mean. The last column will be there in the mean. So that's why I have to there. Mean actually it will be only one observation here. Mean will take only one single observation. Okay. So you will put the point 1, 0.001. I will vary from this part. This 62. It can vary from 62 to 58 or 52. So it will have 10 divisions difference. But number of rotations will more or less remain 11. And then final will be close to 85, 84. If it is 85, it will be 85, 84. So you will have your pitch scale reading more or less same, and then add the circular scale reading, total reading, and then find out the mean. That will give you the thickness of the. Now here, the reading in the thickness will not cause error, because in I also cause an error, in F, so you are taking a difference, right? So you will not be taking 0 and this. Now calculation of mean thickness, we calculate, and then you will have the precautions. What is the precautions? The pitch and the least count is to be determined carefully. The number of observations should be large, and the parallax to be avoided, and the backlash error is to be avoided by turning the skew head always in the same direction. Let me tell you what is the backlash error. I just written that in the precautions. What is the backlash error? I told you what is error. 0 error. Positive and negative. When the main scale 0 lies above positive, when the main scale 0 lies below the 0, the circle is negative. What is a backlash error? Now, when we wrote that in 10 complete rotations, when we went to in 10 complete rotations, it was covering 10 divisions. That's why I said count it 10 times. If it instead going 10 divisions, if it goes 8 divisions, there is an error. It is due to loose fitting between the nut and the screw. There is a tear parts, wear and tear, due to wear and tear. That's why the precaution is always turn the screw in the same direction. Always turn the screw in the same direction. So the backlash error comes only when, that means when at 10 rotations, it was going 10 divisions originally, but if it goes 8 divisions or 9 divisions, the error is backlash error. That will be avoided by turning the screw head always in the same direction.